So in this demonstration, we're going to focus on digital terrain models. In particular, we're going to look at how to build both a TIN, so a vector-based triangular regular network dataset, and also a raster-based DEM, or digital elevation model dataset. So we're going to work with both of these throughout this demo in lots and lots of different data layers. So if you see here, we have several different things we're going to work with. We have some points we're going to work with when we do some interpolation later on. We have contour lines. We have another type of points. Things are called spot elevations. We have water. We have the outlines of some of the different parks that you may be working with. We're just going to focus on Notre Dame again. And then we have an already pre-built raster-based SRTM or satellite source of data. And we're going to work with all of these throughout this demonstration. So because there are lots of different data types, there's going to be lots of different little sections. So if there's only one particular thing that you're interested in, then I encourage you to go ahead and look at the demo notes and try to find that section. So go ahead and start off with a new blank map if you haven't already. And the very, very first thing we do before we want to add any data in is we need to enable two extensions, the Spatial Analyst and the 3D Analyst. Now these are parts of ArcGIS that cost a little bit extra, but are part of the Notre Dame site license. So if for some reason you're at another institution that doesn't have a license for these, then you won't be able to do a lot of these more complicated 3D and terrain modeling techniques. Fortunately, it's pretty common, so I would be surprised if you have a license and don't have these particular extensions. So to enable these, we're just going to go to Customize, Extensions, and then you simply want to turn on 3D Analyst, see mine was already on, and Spatial Analyst. Now if you work off of the same computer, then these will stay in place. If you work off of different computers, or if you're logged in a computer lab or something, then you may have to do this every time. Fortunately, the software will let you know pretty quickly if that's the reason why your tools aren't running. So once we have these turned on, what you would often do in a GIS class is you would go through a scanned topo map and digitize, just like you did for the soils in the Creating Vectors lab, the individual topo lines and the spot elevations on that topo map. I'm not going to have you do that because I think you've probably already gotten the techniques down just by doing those soil maps. So instead, what we're going to work with is some pre-digitized topographic lines. So go to Add in your data. Now again, if you need to know how to map to your data, if they're not showing up with a link to that folder, then look at one of the previous demos. And in Demo 10 data, you should have Michiana contour lines, Michiana spot elevations, and Michiana water. So go ahead and select all three of those and add them in. And what you see is you have a pretty large area of topo lines, of spot elevations, so high and low points, and then the limits of water as well. And we put this in here because when we're creating a surface, we want water to remain flat. We want, if it's a body of water like the lake in Potato Creek State Park down here, or the river itself, we want that to be flat. We don't want that to be interpolated in any way. We don't want the surface to sort of angle in there because that wouldn't accurately represent what we would expect to see for a body of water. Now, the first thing we want to do is use these data layers to create a triangulated irregular network, so a TIN data model. And this is fairly easy to do in ArcGIS, especially when we have all of these different layers. So what we wanted to do is create surfaces between the topo lines and the high and low elevations, but leave the water flat. Now this is going to be fairly, the settings on it are where it's a little bit more tricky, and you're going to want to watch out for how you're doing this. So go ahead and start up your Arc Toolbox if you don't already have it up. Once that comes up, we're going to go into 3D Analyst Tools, Data Management, TIN, and Create TIN. And this will open up the Create TIN window for us. So first thing it's going to do is ask us what we want to output it as. This is just sending it into a temporary location. I don't want it there. I actually want to send it over into my demo 10. And this is one where you're giving it the entire name as well. And I'm going to call it TIN Michiana. Now, if you're not familiar, I'm going to use this word a few times. It's already been in here, but Michiana is just the area of northern Indiana and southern Michigan. It's sort of a clever way of saying the section where Notre Dame and South Bend are. It's going to ask you what the coordinate system you want to use is. You don't have to specify this here, but I would encourage you to do so. We're going to go down to use the same one we've used before, projected, UTM, WGS 1984, Northern Hemisphere, and Zone 16 North. Now if you want, you could just right-click on this and choose Add to Favorites, and if you're using the same computer, this will come up in your Favorites section from then on out. Now, we want to use all three of these data layers, so we're going to bring all of them over. Since they're already all selected in my table of contents, I can just drag them over like this, or I could have chosen them individually in here, or found something that's not even up in my map document by adding it from over here. So it's sort of guessed at what different the settings it wants to use are. So essentially the way that this works is we have sort of what the feature type is, what the height field in there is, and then if there's any sort of tags that we want to have on it. We're not going to worry about tags here. So if we choose hard and soft, in this case it refers to the strength of the edge, particularly whether triangles can cross that edge or whether they're very, very limited at it. Replace would create, given area, kind of a systematic value. Erase will leave it blank. Clip would leave the limits of it, of the entire tin restricted to that. So let's go ahead and set it for each one of these. So for spot elevations, this is true. The height field is elevation, ELEV. If you want to verify that, you could look at it in the attribute table for that layer, and you see that those look like elevations. Because these are points, we want them to be what's called mass point. It should be the only option we have for points, and so that's all ready to go. For the contour lines, contour is the correct one. Again, you could check it in your attribute table if you wanted to, and sure enough, contour is the elevation above sea level. The choice here we have is whether we want to do hard line or soft line. Now hard line, like I said, is going to give it a very layer-caked way of looking at it, because no triangle will be able to cross the line between 2 points along that line. So let's go ahead and switch it over to soft line. That's going to give us a better indication of what it should look like. Now for Michiana water, what we actually want to do, even though there are Z elevations associated with each one of those features, what we actually want to do is turn this to be none. So these are all of the bodies of water in there. We want them to be flat within the model the way that it's been interpolated around it, but not to try to guess if it's higher or lower, not to try to use the values that are already in there. Now we definitely don't want soft clip, because soft clip would go ahead and cut out everything that's around those regions. What we're actually looking for here is going to be soft replace. Now why soft replace? Well, that just means it's possible to have those lines cross over a little bit. So this is the way we want to set it here. Leave all the tag fields as none. Go ahead and leave this constrained Delaunay as blank. If you ever want more information about what any of these tools are, you could always hit this Show Help button right here. And then if I turn this on, it's gonna tell me a little bit more about what that conforming triangulation algorithm is. So go ahead and hit OK. So it'll run for a few minutes in the background. It's got to do a lot of math. It's got to calculate the angle of all of those triangles, the elevation of all the points, and really begin to build it into a system that will show us this elevation in a pretty effective model. And there we go. Our tin has arrived. So if we turn off all the other layers, we can begin to see what's happening here. So you can see it rendering as it goes. If you sort of zoom in on it, you can see that it's showing you a sort of shaded elevation view. So we have the river coming down here. It's all been sort of left as flat, and then we have the banks coming up around it, up onto the hills on either side. So at this point, what we could do is go ahead and convert this into a raster. If we wanted to have this in a system that was a little bit more simplistic for us to do some of these math calculations on. And if we need to do that, that's also in here. If you go into the 3D Analyst tools and go to conversion, you're going to go from TIN to raster. And then you would simply bring over your TIN. Now I would go ahead and call the output raster something like Michiana converted DEM. .tif. And the .tif is important here because otherwise it's going to try to give it to you in a different file format that couldn't have that long of a name, and it'll give you an error. So make sure if the first thing you should check if you get an error is whether you have that .tif at the end. So go ahead and hit OK. So now we have a different type of DEM we could work with. So we've done most of the interpolation in the creation of the TIN, but then it's given us an actual DEM. In this case, the range on it, just like it was with the TIN, is very, very low. So it's not going to be the prettiest DEM just because there's only a few values really in there. Northern Indiana, the Michiana region, is pretty flat in general. If you see one of these for, say, the Grand Canyon or Crater Lake, like what we saw in the lecture, it does look a little bit more striking. So let's go ahead and look at how we might do this in a different way. So we found one way to create an interpolated surface by creating a TIN and then creating a DEM from that. But we could also just go with straight interpolation as well. So go ahead and turn off all the layers that are in there. You can even minimize them down if you'd like to. And we're just going to add in interpolation GPS points here. So what these are simulated GPS points taken across the same region. You can see they sort of look roughly like the spot elevations, but they're not exactly the same. And what we want to do is create an interpolated surface out of these. So we're going to do this. We have a lot of different algorithms. I went over these in the lecture a little bit, and I encourage you to spend a little time looking at different algorithms if you want to. But what we want to do is we're going to just use the spline algorithm, which is one of the more simplistic as far as settings go, ones that we could do. So go into your ARC toolbox, go down to Spatial Analyst tools, go to Interpolation, and then we have, say, inverse distance weighting, Kriging, natural neighbor, lots of different techniques in here. And we're going to choose spline. So you're going to bring over your point features. It's going to immediately ask you what the Z value is. It's elevation 11 here. I'm going to give it a permanent output name. I'm going to call this Michiana Interpolated DEM.tif. The only other thing that I really want to set in here is I'm going to turn down my output cell size. It's guessed at what it thinks I should do based on the extent of the file, but I want it to be a little bit more precise than that. So I'm going to go ahead and turn it down to 30. And this will just give it a better surface. So that'll run for a moment or two as it's kind of guessing at the points in between all of the points, all the area in between the points. And it's going to build it up for us in a way that has a nice view of the same area. So I'm going to turn off the interpolation points. We don't really need those anymore. And what it's done is it's given us something a little bit silly here. So it's given us some really low values. That's normal. Sometimes with spline, if there's no data, then it'll give you like very low or very high values. But it's given it to us in this sort of classified way, which doesn't really show the data the way that I would prefer to for a DEM. So I'm going to go ahead and go into the layer properties for that DEM, either by double-clicking on it or right-clicking and choosing Properties. And I'm going to go over to the Symbology tab. And we're just going to choose, instead of Classified here, we're going to move it back over to Stretched. And then I'm going to go and switch it to one of those traditional color ramps that we associate with topographic data. It's this one right here and that one right there. So if those don't make sense, if you can't immediately see those and have them look totally normal, anytime you see this color ramp in ArcGIS, you can right-click on it, turn off Graphic View, and then you'll see that those two are just called Elevation 1 and Elevation 2. It makes it very, very easy to find the same color ramp again. So go ahead and hit OK. Now this looks more like an interpolated surface. You can see that there's some little ball or high and low points. It's a rubberized surface, a spline method, so it's going to look sort of like this. Now we can compare that to the DEM that we generated from the converted tin, and it's probably a good idea to go ahead and put that into elevation, the same color ramp, just for ease of sort of looking at these. So you see one definitely looks a little bit more pixelated, but it looks a little bit more like what we would expect to have as the true surface, and one has some artifacts of that interpolation in there. This is relatively normal. So let's look at one other type of topographic data before we start thinking about some of the different ways to do topographic analysis on these layers. So we're going to just add in this other layer, which is SRTM Michiana UTM. So what this is saying is this is the shuttle radio topography mission from the latter part of the 20th century, I think 1999. And then it's from Michiana, and it's using a UTM projection. So this is just the name that I gave it to sort of make sense to have a lot of the data that we needed right there. So just add that in. What you'll notice first is it's a little bit bigger. The values are roughly analogous to what we have for the other. They go from about 200 to 275 in one and 150 to 300 in the other. And these are probably a little bit more accurate, and they go from 180 to almost 300. So let's just change our color again as well. And now we can begin to look at all three of these and see which ones we think are giving us the best information. So if there are any deviations across them, it may be the case that you have missing data. Those GPS points, they may have not been a very, very consistent, like finding all of the spots that there really are important topographic changes. It could be that you could edit the original file, build new ones. You could create a better tin out of some of the other points. And sometimes you would even need to make points or polylines to kind of trick the computer into creating the right surface for you. And that's a technique that you can do. You just need to be clear that you've done it in any further analysis. So at this point, we no longer need most of these sort of simple surfaces here. So we don't need any of the vector data here. We don't need the interpolation points. We don't need the contours. Just right-clicking and choosing Remove. And in fact, we're just going to go ahead and stick to our converted DEM and our tin. So for the rest of this demo, we're not going to need the SRTM data. We'll return to it in the next demonstration, or a further demonstration on hydrology. And we're not going to work with the interpolated surface any longer. So what I want to show you at this point is how to do some of the different topographic analysis on both DEMs and TINs, because the system is different for each one. So the standard ones that we've talked about before are things like the slope, things like the aspect, things like hill shade, contour lines, any of these different things. And we're going to start off doing this on the DEM. Now the big difference between doing it on a DEM and doing it on a TIN is a TIN, you can do it on the fly. You can just change how it's displayed to show you any one of these different characteristics. For a DEM, you're going to create an entirely new raster layer that is that calculated surface. And that's an intentional choice. That way we could use those layers in different types of analysis later on. So to start off, we're just going to do a slope raster. Is going to be our first one here. And most of the things we're going to work with are going to be in the Spatial Analyst tools in Arc Toolbox and down in Surface. So let's go ahead and run slope. And we simply bring over our DEM as our input raster. Our output raster, I'm going to call it Michiana slope. .tif. It'll let you set the output measurements if you wanted to have any sort of z factor, if you wanted to convert at this point between meters and feet or something like that. So we're going to go ahead and hit OK. It'll take it just a second to run, and now it's given us a measurement where the slopes range from 0 to 7.6 or so of the areas of higher slope in red and lower slope in green. Now obviously, if you're doing this for a different area, the values in there are going to change. But this is sort of the standard color ramp for slope, this sort of green through yellow to red. So the next one we want to do is to look at the aspect, or the prevailing direction of every pixel. And it's exactly the same. We're just simply going to bring over our DEM as the input raster. We're going to call the output raster Michiana aspect.tif. And once that runs, it's going to give us a slightly different measurement where we have anything that's flat. It's going to be a -1 is the value. It's in sort of gray. And anything that's north, whether that north is 0 to 22.5 degrees or 337.5 degrees to 360 degrees, is in red. And all of the other kind of sections of the compass are colored in different ways. Now it is presented as categorical here, but underlying it we have the actual angular values. So for any individual pixel, if we wanted to use the identify tool and click on an individual pixel in there, it's actually giving us that angle, 104 in that case, so something that's going to fall into this generally kind of east category. Now we'll get to, in a later demonstration, the concept of reclassifying. And these data are frequently reclassified so that whatever your prevailing direction that you want is much higher than, it gets a higher value than the directions you don't want. Now another one we can do is called hillshade. Again, we're just going to bring in our DEM. Going to call it Michiana hillshade. .tif. And then it'll allow us to set our azimuth and our altitude, so the angle that the sun is coming from and the angle above the horizon. We could do some of these other options if we wanted to, but I'm just going to leave them as is. And what this will end up giving us is a layer that, for that particular orientation of the sun, is showing us the areas that are more shadowed versus the areas that are more well lit. This can be very useful for things like putting solar panels or understanding different vegetation regimes that are sort of based on climatic characteristics. Now I'm just turning some of these off, minimizing them. Now the last one we're going to do is one that doesn't actually give us an output of a raster. It'll actually give us a vector output, and that's this contour one here. And what this will let us do is create a new contour line layer. Using whatever DEM we have, we can now create, I'm just going to call it Michiana rebuilt contours. And it's going to give us a shapefile. So if I wanted to give it, say, every 2 meters, it'll give me a contour of every 2 meters. Now in this case, this isn't exceptionally useful because I've already built it off of a contour layer. I have one already. But say I downloaded a raster DEM from someplace and I wanted to create a contour map, something that someone else might be able to see a little bit more clearly what's going on. This would be how you would generate a contour map from something. So you can see that even though it's a little bit pixelated, so some of the lines are a little more straight than what you might normally see, it has created a nice contour map for us out of this layer. So those are the main ones that we want to do on the DEM. Now I want to show you how to do some of these on the tin layer because it's a little bit different. So I'm going to turn off everything but the tin. It's just taking a second to render. Zoom out a little bit. Zoom in a little bit more. Now when I want to set different things to see some of these different characteristics, all I have to do is go into my tin, the properties for my tin layer, go over to Symbology, and then it's actually giving me a list of different things I can see over here. So right now I'm seeing the edge types and elevation. I don't really need to see the edge types. I can remove those, and now it's not showing me those contour lines anymore. But I can also add a bunch of other things in. So if I wanted to hit add here, I can do my face aspect with a graduated color ramp. So I'm going to add that. My face slope with a graduated color ramp. If I wanted to do contour lines and elevations, I could have all of these in here as well. So I have a lot of different things that I can show on my renderer here. So once I'm done with adding, I'm just going to hit dismiss. And now all I have to do is turn off slope, turn off elevation, all these other things. And now what I'll see in the background is the aspect. If I do the same thing for slope, whichever one's on top and turned on is going to be what I see. And I can always reorder them if I wanted to here. So I can show my hill shade effect down here, even in 2D effects, or even in 2D sections. And if I want to, I can always go back to elevation. So I'm just sort of showing my elevation here. I could change what the colors were. I could change pretty much anything I wanted in the Symbology tab by choosing what layer and then choosing things in the Symbology. So it's a lot easier to show these things interactively with a tin. I don't have to create a new layer, but what that also means is that new layer isn't available for me to use in any further analysis later on. So just to sort of finish up, I want to show you a few of the things that you can do that are a little bit even more interactive than working with tins. And we're going to do that by turning on the 3D Analyst toolbar, which gives us some things that we can do just sort of on the fly. So again, to turn on a toolbar, you're just going to find a gray spot at the top of your screen, right-click, turn on 3D Analyst. I'm just going to drag mine up here and dock it. Now, like a lot of these, whatever layer I have this pointed at is going to be the one that I'm working off of. And then I have a lot of other tools. So I have a drop-down with a bunch of options I could set if I wanted to. I'm not going to change anything at the moment. And then I have a lot of other sort of interactive things I can do over here. The first one, what it's going to do is it's going to create a single contour that shows me everything that's at that same elevation. So if I click, sometimes it's hard to hit a good spot. If I click right there, it's now showing me everything that's at that exact same elevation. The second one here is going to create what's called a steepest path. So if I hit someplace up high, it's going to show me eventually. Again, these are very hard to hit on something like a tin. It's going to show me the steepest path down from wherever that point is. Obviously, I'm not hitting any very well in here. So I wouldn't really worry about those too much. The next one here will show you what's called a line of sight. This is a type of viewshed analysis where if I can now set my observer. So say, in this case, these are meters. So we'll say 2 meters. It's a very tall person looking at something that's, say, 5 meters tall, looking at a building. So now if I click my observer and then my target, I can see whether or not they can see that thing, what's blocking it, and anything that's visible in between the observer and the target. So you can create these sort of across the entire thing. Finding one that you can see a big area is usually relatively difficult, though that's a pretty decent one right there. I can also do things like create an interpolated point, line or polygon across the surface, so it's actually going to give me something that's a graphic, although not a true shapefile or vector data, that's going to give me the ability to kind of copy that between different ArcMap documents and not do a lot of analysis, but have that same thing visible. It can be useful when you start working in 3 dimensions. Eventually, you'll end up with a whole lot of things on here that are drawings. If you are tired of them, you can always go to select elements, sort of drag around them, and then just hit delete. You might have to find ones that you missed and just get those as well. But if you just choose them with this black arrow tool and then delete them by pressing the delete key, it works pretty well. So the last thing, I'm just going to show you one interpolating a line here, because this is the one that's actually pretty neat. So if I go through here and I choose interpolate line, what it's going to do is it's going to place that line graphic that I just created across the entire surface as well. It doesn't look like it at the moment, but what I can also then do is go to this profile graph button right here. Once I have something like that interpolated line selected, I can choose profile graph, and it'll generate for me a graph of the topography of that line. Now that could have been a complicated line, it didn't have to be a straight line, but it's a good way to give yourself a good profile graph of a particular area. If you need to change any of the specifics on here, it's basically up if you right-click on the title someplace and go to Properties, you could change all of the different titles and subtitles and units. Now the last part of this that's pretty neat to do, I'm just deleting that last one, is if I create a line of sight, I can do that same thing. I can create a profile graph for my line of sight that'll show me, just dragging it out a little bit bigger, maybe why I can't see that anything. So I was behind a hill is why I can't see anything on the other side. So it's a good way to be able to create an interesting visualization of the 3-dimensional surface. So we'll work with these and some of the other 3-dimensional tools in a later demo. Particularly, we also have the ability to go into the 3-dimensional versions of ArcGIS, ArcScene, and ArcGlobe. We'll work with these in a later module. So that's essentially it for working with topographic data, DEMs, and TINs. In the following demonstration, we're going to apply some of these skills when we start working with spatial modeling, both hydrological modeling and sort of more generic modeling. I do encourage you to take a look at whatever assignment there is for you for this week, for this module, and feel free to contact us with any questions. Thank you.